Does anybody know what dynamic geometry software is, or has heard of, Geometry Sketchpad, or has used it? Heard of it? You've used it. Anybody else?
Our teachers use
Your teachers use it?
It's more high school level classes that use it.
Okay, the high school levels use it more? Do you know what it does? Yeah. Is anybody completely unfamiliar with Geometry Sketchpad?
Well, we all saw what JD's right.
I've heard of it.
Say that again?
We all saw what JD's right.
Yeah, that was, yeah. So, dynamic geometry software, there's, I called this in CanLead. The examples are going to be specifically Geometry Sketchpad. However, there is, which I'm not very familiar with, I think a free internet program called GeoGebra that basically it runs Geometry Sketchpad files. So Geometry Sketchpad is a software program that you have to buy, but GeoGebra, I've heard, does the exact same things and can run Geometry Sketchpad files.
And it's on our standard student image, as is Google SketchUp, which is not dynamic.
Yeah,
But it's cool.
but yeah, it's pretty cool.
Sketchpad
So-
or GeoGebra?
Both of them, SketchUp and GeoGebra. are
No,
on there.
Sketchpad.
No,
No, Geometry Sketchpad's not, because we don't have district-wide license for it.
well, you might, because all the high schools have it. I know Sarah has it, Sarah Terrell, at Jack Jewett.
I don't think we don't have district.
You saying?
And,
Jack Jewett, of course, has it.
Shoot.
All the rest of it.
Walton has it. Walton has it because Paula's used it.
Wait a minute.
Wait a
So
minute.
I
You need to get on
think
this.
you may have it, you don't even know it. So, well, anyway, does anybody want to talk about, anybody that knows a little about it, do you want to share what your knowledge? Is will listen to me talk forever? Well, okay, you saw the sine wave this morning and the limit definition of a sequence. So what can you gather from those two very short, brief examples?
You can create your own simulations, your own mathematical simulations with the Sketchpad software.
Okay, yes, you can create, use the animate button to make them like a simulation. Or, Joe created that one, but I can still use it, so what can you do with it? You can share them, exactly. So you just save it as a Geometry Sketchpad file, and every time I can now open up that same sine simulation without having to make it from scratch. But when you go to Geometry Sketchpad, it looks like this. So how in the world did you get that beautiful sine wave from this?
You have him send it to you.
Very good.
That works.
Yeah. So basically, the example up on the website right now is an 8th grade illustration that, again, the front page talks about all of the whole TPAC, about everything that Sketchpad can do. The 8th grade illustration is specific to an 8th grade SOL. In this instance, it is the Pythagorean theorem. And then if you go through the steps, the try, you're going to have, again, an activity guide to walk you through an activity talking about the Pythagorean theorem, proving the Pythagorean theorem, and basically proving and conjecturing all those good things that we love to do in geometry. However, Geometry Sketchpad is a complete misnomer. You can do algebra activities, you can do, obviously, you saw the trig, you can do the calculus, you can do, it should be called the mathematician sketchpad, because you can really illustrate just about any and every, I'll put in quotes, math concept. They have graphing capabilities, or it has graphing capabilities, so we'll go back to Sketchpad now, I'll just give you a super brief overview. As you look along the top, you see graph, so you can make a polar grid. Does anybody remember polar coordinates?
Yes.
Yes. So what should the polar grid look like? Circles, right? It's not the square grid. So here, I love this activity. I put this up on the smartboard. Let's plot some points. Matt, come up to the board and plot -5, 3.
You're asking me because I don't know if I can reach that?
But you get my example. So I opened Sketchpad and you saw I went to graph and just turned on the graph. So now we can, with the smartboard or interactive whiteboard, we won't need to plug any specific. I know at the high schools the Promethean boards. I don't know what you guys have at the middle schools. So the interactive whiteboard, you can plot points. You can start practicing graphing. You can physically graph functions. So graph, new parameter, new functions, plot functions. So again, that's why it's not just geometry. However, I think the reason they don't want to shy away from Geometry Sketchpad is because it does do a lot of wonderful, wonderful geometry concepts really well. Okay, okay,
Can you use it with airliners?
Yes.
Wait, Joe has their
Because some people are putting in for transfers.
Yeah, we know Walton has. Walton has it all.
Yeah, the airliners and not the smart boards. So let's think of some basic geometry concepts. I know, this is a throwback. So what is the most basic geometry? Figure? Is that the right name? Triangles are close, but even more basic. We'll come back to triangles. Hint, it's up there. Oh, what's a dot in mathematics? A point. Okay, perfect. So we look here. What do you think the point does? Plot some points.
Imagine that.
Imagine that. So now, I also heard the next step up is a line. How do you make a line? Or how many points do you need for a line? 2. So, the annoying thing about Sketchpad is that it kind of has a steep learning curve. So every time you click on something, you can kind of see it's kind of faint, being small, but that point is highlighted and none of the others are. So if I wanted to construct a line, it's all grayed out. It doesn't let me do that. Because how many points do I need to make a line? 2. So you have to make sure that 2 points are highlighted. Now you can go construct a segment, array, or a line. So that's how you can, it builds in those geometry concepts that you really want to instill, those basic concepts in your student. And that's the one really good thing about it that I like. So we talked about triangles. How do I make a triangle here? 3 points, 3 lines. So I can use the line segment tool, which is this guy, and just make a triangle. And I can get rid of that guy, because I didn't want him that long. So perfect, beautiful. I got a triangle. How easy was that? So now let's explore some properties of triangles. We can talk about measuring angles. And not only did it measure that angle for me, but now it labeled it. So now we can reference angle ABC, which means which vertex? B. And you can do that now 3 times to get each of the different vertices. That's what I mean by it. You got to make sure you click in the correct order, measure angle, and then measure. So if you notice, I have to click 3 points to measure the angle, and then the middle one is the actual angle. Now we can also do, how do you do calculate, measure, calculate?
Yeah, calculate.
So measure, calculate, and then I can do
Just pop it in.
that plus this guy plus this guy. So now I just added up all the angles. How many degrees should it be? 180. And guess what? No matter what triangle I have, I can manipulate this triangle. What happens? The interior, so look at that. We're doing geometry. So making predictions, making conjectures, all those beautiful things. Now, is this a proof? Does this prove that every single triangle, the interior angles always sums to 180?
Approves of that triangle.
It's not until you start messing around with
Move the points.
Getting close. So yeah, it's not exactly a proof, it's not a formal math proof, but this is where you can, have those discussions with your students. Put them in the mathematician's role. It doesn't necessarily need, this train, that train, all this made up context. You can have context just in the activity itself. So challenge your students, okay, how would we actually prove this? Does it prove it once I move it around? Have I hit every single triangle in the whole entire world? No, even if I move it around with every point all around. So those are just some things that, when I say Geometry Sketchpad does geometry really well, that's what I really like about it.
I did this activity in a geometry class a couple of years ago, and I asked the kids, is it approved? And a bunch of them said, yes. Some of them said, we think so. And then one said, I really hope so.
So let's see, now how would I make a right triangle? What do I need to do to this guy?
Pull it to the right.
At one angle be 90 degrees.
Okay, so let's say angle C, we'll try and make 90. 77, 80, oh, 90, oops, I don't know. So, it says 90.14. You can also change the display so it does or does not display the decimals. So if I didn't have the decimals on, that would say 90 degrees. So, it still wouldn't be. Yeah, it was just saying that. Trying to get to
Looks
that
like 90.
random. So, that's not the best way to make a right triangle, if you ask me. If we're investigating the Pythagorean theorem, so what geometrically is a good way to construct a 90-degree angle? So you can also differentiate between constructions and drawings. What would we construct if you were Euclid and you had your compass and your straight edge?
Perpendicular line.
Perpendicular lines, there we go. So I can we can just start a new sketch, we can delete what we have, all that kind of good stuff. So start with a line, we need 2 points, we need to highlight both points, construct a line, and now we need a point not on the line. So we want the point and we want this line and we want to construct perpendicular lines. So now we see we have that perfect 90 degrees no matter how we wiggle any of these points. I gotta create that. And we can also construct the intersection. But still, and then, so basically, now you can kind of see, I don't necessarily need to go through all the points with you guys, kind of how you can start with the basics. A point, a circle, and then the line tool just kind of makes it easy. But think about what Euclid had, and you can discover all of his propositions, conjectures, what are they called? His 4 postulates. There we go. That was the P word I was looking for. So you can start with your compass, your circle tool, and your straight edge, which is your point or your line maker, and use those to do constructions in Geometry Sketchpad. The beauty of Geometry Sketchpad is also, as we were talking about, you can open up files that have already been created. So here's a right triangle tool that's already been created. You can also create custom tools that allow you to every time remake. So that custom tool is a right triangle, so now every time I do it, you know, kind of like when you're in Word and you pick the square or pick the different shapes, you can now recreate that special shape, so you don't have to start from the beginning of the construction. And then you can just go through the activity, open up the different sketches, or create the sketches yourself, because that brings up all of the mathematics behind, like how do you make a square? Okay, we saw how to get the 90 degrees. Now think about, what do I need to make a square? And if I only had my straight edge of my compass, what would I do to make the square? So this activity for 8th grade kind of draws on, you need a little bit of Sketchpad knowledge to do this with ease. It's not impossible because we've already created some of those basic sketches for you. But what we're going to do is basically have that 6th grade illustration be a very step-by-step, start with the blank and learn the basics of Excel. Excel, Geometry Sketchpad. Okay, any other questions? I think you've seen now start with the basics, the point and the line, creating triangles, creating perpendicular lines, and then you saw the sketches that had the sine wave and stuff. So you really can just basically, the sky is the limit with Geometry Sketchpad. You can go nuts. If you Google GSP anything online, you can probably find a Geometry Sketchpad file that has whatever you're looking for. And again, we'll have a resources page that has a bunch of sketches for you to download.
In terms of simulations, I taught calculus, and we use this thing called Calculus in Motion.
Yes.
And it has all the files that you can get to these, and they're amazing, but they also have Algebra in Motion, which the supporting files for Algebra in Motion have all the basic things that you learn in pre-algebra. So it's just an amazing way for kids to really see and fool around, see the concepts.
Well, here's Calculus in Motion. I think I'll put up Algebra in Motion, but basically, so as Matt was just saying, so again, that's why I said Geometry Sketchpad is a misnomer. They have a ton of pre-made sketches. This is an example from Calculus in Motion. As he said, there's an Algebra in Motion. I can show, I don't know what a good algebra is.
I have it somewhere, just, I think. I
Yeah,
don't
I
think I
have
loaded
one on
it
my
in.
little flash drive, but of course it did not work. So we'll put up the sketches according to either SOL, definitely by grade level, and hopefully by SOL specific.